Hello, welcome back to the channel. So let's continue our previous videos and do one more question on solving indefinite integrals using partial fractions. And before watching this video, if you have not watched my previous video specifically, I would highly suggest you to first watch that video because that video will cover very important concepts that we discussed which will help us to solve this question very easily. And you can always find that video on the I button above, or if you click on the description as well, you can also find that video over there as well. So in this question, you see the same pattern which was present in the last video as well. The degree of the polynomial in the numerator is equal to the degree of the polynomial in the denominator, which is definitely not what we want if we want to use partial fractions, right? So we'll have to do some manipulations to this expression over here such that the degree of the polynomial in the numerator is at most 1 less than the degree of the polynomial in the denominator, right? So this is the concept which we already covered in the previous video. That is why I will highly suggest you to first watch that video if you have not watched that video before going over this question calculation in detail. So again, we'll use long division first in order to simplify this expression over here. So if we use long division, we know that we are dividing 4x to the power 4 plus 14x squared plus 2 by 4x to the power 4 plus x squared, right? So we know that we'll multiply it by 1 first because we want a 4x to the power 4 term. So if we multiply this expression by 1, we will get 4x to the power 4 plus x square over here, right? And subtract. This will cancel out. So this will be 13x squared plus 2, which will be your remainder. 1 is your quotient, this is your divisor, and this is your dividend. And now you know the division formula again. You know that basically dividend is equal to quotient times divisor plus remainder, right? So dividend in this expression is this one, 4x to the power 4 plus 14x squared plus 2, right? Your quotient is 1 and your divisor is 4x to the power 4 plus x squared. So 4x to the power 4 plus x squared, since your quotient is 1, so we won't include that, plus your remainder. So what is your remainder in this case? Your remainder is basically 13x squared plus 2, right? So 13x squared plus 2 is your remainder. And now since we want this expression at the end, we'll basically divide the left hand side and right hand side by 4x to the power 4 plus x squared, right? So if we do that, 4x to the power 4 plus 14x squared plus 2 upon 4x to the power 4 plus x squared equals 1 plus 13x squared by 2 upon 4x to the power 4 plus x squared over here, right? So now we have easily simplified this expression into this expression, and now in this case you can clearly see that the degree of the polynomial in the numerator is 2 and the degree of the polynomial in the denominator is 4, which is definitely allowed if we want to use partial fractions on this expression over here and split it into individual components for which we already know the indefinite integral for. And now we know that we have to calculate the integral of this expression over here, which can be easily written as integral of this expression dx as simply integral of 1 dx plus integral of this expression dx in this case, right? So now calculating the indefinite integral of this expression is easier than calculating the indefinite integral of this expression, right? But now we know that we can further simplify this expression over here using partial fractions. So let's write this expression over here. So this expression can be easily written as 13x squared plus 2 upon 4x to the power 4 plus x squared. And we know that in order to use partial fractions, we want to have factored out terms in the denominator. So we can easily change the denominator by taking the x squared common, and it would be simply 4x squared plus 1 in this case, right? So now you have this expression over here. Let's write this expression 13x squared plus 2 upon x squared 4x squared plus 1 on the left hand side, right? And now you know that for your factored out terms in the denominator, you know that these expressions cannot be factorized further. So now you're good to go and use partial fractions in order to simplify this expression over here into multiple individual components. And now in order to do that, you know that this expression will be converted to, so for the x square term, we will have a upon x plus b upon x square. And now for this 4x square plus 1 term, we will have cx plus d upon 4x square plus 1 over here, right? Again, in order to simplify this expression, we use the same concepts that we discussed in the previous videos. So now you can solve for your constants a, b, c, d by basically equating the numerator on the left side with the numerator on the right hand side. So if you do that, you'll basically get 13x square plus 2 equals a times x times 4x square plus 1 plus b times 4x square plus 1 plus cx plus d times x square over here, right? So now you have your numerator expressions equated, and now if you'll compare similar terms on the right hand side with the similar terms on the left hand side, you can solve for a, b, c and d, the same process that we followed in the previous video to solve for a, b, c and d, right? And now if you'll do that, you'll basically get the values of a, b, c and d to be these values over here. So now you can easily convert this expression as simply, you know the values for a, b, c and d. So you know that the value of a is 0. So you will not have a 1 by x term over here. Your b is 2. So it would be 2 upon x square. Your c is 0, d is 5. So the second term would be 5 upon 4x square plus 1 over here. And now finally, if you want to calculate this indefinite integral over here, you can easily simplify this integral over here to just calculating the integral of 1 dx plus the integral of 2 upon x square dx plus the integral of 5 upon 4x square plus 1 dx in this case. So we basically converted this expression to this expression over here in the integral sign, right? And now you can clearly realize how easy it is to calculate the integral of these three expressions over here rather than calculating the integral of this expression or even the integral of these two expressions over here, right? So that's it for this video. Again, I'll leave the integral calculations to you, and I would highly appreciate if you can comment down the answer to this integral in the comment section below. Feel free to comment down in the comment section below if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.